This conference will now be recorded.
Maybe another 15-20 days, maybe 1 month to see the full summer.
Viraj, did Bhumesh forward you my resume?
Yes, because I didn't get a chance to look at it, but definitely Monday we will go through that. I'll over the weekend at least I'll review it. On Monday
Yeah,
we can
I'm
get
really
it.
waiting on your reply. If you get it, yeah, it's okay. We can go ahead. If you say something like that, I'll start
Uh,
marketing that.
okay, sure, definitely. So we can Monday after the session we can just have a review and any suggestions, any updates. Before that, if it is done, I'll forward it to Bhumesh.
Okay.
If there is something on the call we want to discuss, then on Monday we will do it. Huh?
Okay.
That's fine.
No worries.
All right. Um, so how about a new topic today?
Start the
So
pipeline,
we'll
right?
start with Docker. Yeah, we're done with the pipeline. So one last point in that is to have the tools in the pipeline, right? In the different and the stages we want to integrate like SonarQube, Artifactory, and also we want to deploy it. So that
Yeah.
example we'll have a look at it.
Okay.
Uh, that needs some setup as well. So for that, Docker is needed. So we'll install all SonarQube, Artifactory using Docker, and also Ansible we haven't covered. So that also we'll see that one. So
Mhm.
this is very interesting, and Docker is important. Ansible we can still keep it for the last. But Docker and Kubernetes are important, so that's why I thought let's start with Docker first. Okay, let me. Okay, okay, let's try to understand how Docker came into picture. Um, Before Docker, it started way back in early 1990s only. Like containerization concept was there around 19 end of 2000. It all started, but it only became popular because of this company called Docker. So which was released in the year 2013. Sorry. And the whole concept of containerization was always there before like starting of 2000 it all started. So we'll try to understand why this what is this containerization um, and what are the concept and architecture behind this Docker. And we'll also try to compare how this Docker containers are better to virtual machines that we already had at that point of time. Okay. We'll come to why Docker. So basically, we can isolate. Okay, once we understand what is a container, we'll come to know that where we are isolated. The applications are isolated. So one application on a single virtual machine, we can have multiple applications running, and they're all isolated. So that it is still the same. Like when we consider a Windows machine, you can run n number of applications. All of them are isolated. In the same way, here process level isolation was being done, and it was very lightweight. We'll see how it is lightweight, and we can have a workflow like we can have multiple let's say one is an application container and other one is a database container. So we can create a workflow and they can interact and talk to each other over the internet or the network basically. So these concepts will go into little more detail. Let's try to understand a little bit of differences between how the virtual machines and Docker containers looks like. So this is a difference, but the main reason why Docker came into picture is um, it happened like whenever there were some issues, okay, in order to reproduce that issue, it was a big challenge. Let's say issue happened in the production. In the olden days, like see, the environments were different. Like even now they are different. Like date, fate, integration, pre-production, production. So if you want to reproduce something and you don't have an environment, like in production on the live, you can't go and reproduce the issue there, right? You have to bring it down to either pre-production or the lower environments. So there was a challenge, and if you want to fix something by the developer, you have to set up all the same setup on the pre-production, and then you go and reproduce the issue and fix it. Or let's say you want to try out some new fakes, you don't know the fakes, or you want to go with a new feature, for example. In that case also, you don't have the entire environment to try out or experiment in that case, right? So for that reason, they thought of something like containerization. Okay, why not put everything into one like a bucket, and which we can ship it. Okay, let's say we have developed a new feature and we want to ship it, the entire environment, to the client. Let's say client, whether we don't know whether the client likes that um, feature or not, but at least we can ship that entire environment so that the client just clicks on it and he'll be able to view the web page, and from that he can give us the feedback. And let's say the testers also can utilize it to test some new features or any fix that the developer has done, right? So that was the idea how this containerization came into uh, the whole idea means behind the containerization that came into picture. So the thought of putting all the environments, all the required libraries for your application into one place, including the operating system, right? So that's how the containers were born, right? And it all started 2000, and now here we are with the Docker in 2013. This is how it looks like. Okay, we'll quickly compare what the virtual machine provides and what the Docker provides. Okay, in case of a virtual machine, let's say I want to deploy an application, I need to have a guest operating system. Let me take the pointer. Okay, so you need to have a dedicated resources allocated here, right? Anytime you might have used virtualware, VMware, right? VirtualBox or VMware. There you need to say this much of RAM you are dedicating, this much of uh, hard disk you are dedicating, right? So you need to have a dedicated resources allocated in these scenarios. Like and on top of that, you're running a operating system, and then you'll need to have the necessary libraries for that application. It goes on like this, right? So the problem is you need to have a huge you need, let's say you need to have 3 virtual machines. You need to dedicate the resources like separately for all of this. And if you want to run them in parallel, all of your resources will be blocked, all right, in this scenario. And only you're running one application. You cannot scale up. If you want to scale up to another application, probably you need to create one more virtual machine and then do the whole round of installing the operating system, libraries, binaries, everything, right? It's also time consuming. So this was one of the another point wherein Docker came into help out, and you can see this side how the container is looking like. So we have a server, we have an operating system. These containers make use of the underlying operating system. You don't have to worry about that. And whatever the necessary binaries and libraries that are required, so only those will be bundled in the container. All right. Any let's say Java is required for one of the application, so that prerequisite along with some libraries required for that application to run. And it is very easy to scale those containers on the same machine. Let's say we have a capacity of let's consume 8 GB of RAM is there. Okay, so internally for your operating system, it takes 2 GB. Let's assume it takes 2 GB. So remaining 6 GB of RAM is available for the application. So let's assume that one of the application, it takes uh, let's say 0.1 CPU and around 300 MB of RAM. So you can imagine like how many applications you can create on the same host operating system. So you can scale up the application and utilize the resources to the fullest, right? So these are some of the benefits that came out of containerizing the application there. Okay. So any question on this architecture or on the containers? So is it clear?
Yes.
Yeah.
All right. So let's look at what are the things that we can deploy using Docker. The web apps we can deploy, the backends, any of the backend servers, SQL Server, NoSQL. So all of these things like big data, right? These all can be deployed using Docker. Okay, and it has got. Okay, let's go to the first slide and try to understand the architecture of little bit of architecture about Docker. So it has got a client. Client is where we can build the images and pull the images and run the images. So this is on the CLI mode. And behind the scene, there is a Docker daemon that is running. So which will facilitate creating of images and running of containers. And there is a registry like Docker. It has got its own register like Docker Hub, where you can store all our images, our application images. That is publicly available for anybody. But in organizations, what they do is they have their own repositories. We can create own repositories or a hub wherein you can store all your application related images there. Okay, there'll be private registries that they are created in the organization. They don't go for the Docker Hub, which is basically if you want to store anything related to the community or any community wide can use it, then you can go with the Docker registry. Okay. So the main concept here is to build it, ship it, and run it as a distributed application. Right? So on the CLI, you're going to build the image, and then you can ship it to a registry. As and when it is required, you can pull that image and then run them as a container. Okay. Now let's there's a simple difference when we say image and a container. Image is just like think of you got a hard disk And on that hard disk, you want to now install an operating system. Okay, you take a CD drive, and on the CD drive you have that software to install the operating system, right? You got an image basically. So once you start installing it, that that becomes alive, and you can see your operating system, or let's say Windows operating system, alive. So that is your running instance of the image. Okay, that running instance of an image, you call it as a container. Okay, and the image is read only, but when it comes to container, there is one more write layer added to it, so you can persist those changes and again save it as an image. So once the container is running, you make some changes to the files or some system, those changes can be persisted and can be created as an image. Okay, so any running instance of an image, we can call it as a container there. All right, so on the CLI mode, there is something called as Docker engine. The Docker engine, we have the Docker daemon that is running in the behind. So once you install the Docker engine, so we'll have a Docker daemon as a service that is running behind, and we'll get a Docker CLI mode. The CLI mode, we can build the images, run and manage the containers. Okay, so these are some of the commands that we have. We can build, we can run, we can stop all the containers. We can list some of the containers using this command. So we'll look at the CLI mode. Let's go and install the Docker on one of the machines, and we'll try to go with all these commands. Okay. Let me take the same one. Okay. Let's go to the Docker URL and download the Docker file from there. So we'll install Docker on CentOS. So we'll install Docker from a repository. So for that, we need to have some set up the repository. Let's install this first. These are some of the dependencies that are required to install the repository and run it. It is done. So let's clear this. We'll also install the config manager, and we'll add this repository. Just we'll install this one. Now this Docker repository is added to our yum repository here. Okay. So now we can run the command like this one, sudo yum install docker c. It's a community edition, so let's run this one. Okay, so now the Docker should be installed. So we'll go with the command sudo docker. Yeah, it is installed. Okay, I'll also let's go to the Docker Hub once, and we'll see how the Docker Hub looks like. Okay, this is the Docker Hub where we can see all the images are stored here. Okay, so you need to sign in, and let's say I want to search for image called Jenkins. I can search for that. Like you'll have lots of results. So usually the official image, people download the official image. Basically they trust the official image and they can download it. And if I just click on this, I can go and download this image. Okay, like this, I can pull this image. So what we'll run is we will pull a Ubuntu image. So what we'll do is Docker pull Ubuntu. Okay, it is saying the Docker daemon is not running. So let's go and Docker daemon. Okay, it is started. Now let's run this Docker pull open. So if you don't see what it is doing is there are tags. Tags is like the version. If you don't give anything here, it will take the latest as a tag and it will download the latest from there. So now a Docker image of Ubuntu is pulled. So if you want to check that, we'll go with sudo docker images. Should be able to see this repository. The tag is latest. This is the image ID, and this is the size of the file there. Okay. Now, if you want to run this, I can simply go with the sudo. Now, this is just an image. I want to run this as a container. Okay. So you can go with the sudo docker run. Let's go to the help option. There are a lot of things in the help option here. So if already the container is running, I can attach to the container with -a. I can go with any environment list. I can go with -e. I can run in a detached mode. That is, the container will be running in the background. So if you want to run the container in background, you can go with the -t. And there is interactive mode. Let's say you want to interact with the container, then you can go with the interactive mode. Interactive mode means wherein you can provide some standard inputs, right? And those will be passed to the containers. And if you want a terminal, like the shell, if you want to get a shell, then you want to go with the -t. Okay? And we'll see like a lot of things like publish ports and all. We'll see what it is. Also, there are options wherein you can attach some volumes. Volumes is like some kind of folders you want to attach to your container, because your container doesn't hold any data. So as long as container is running and you destroy it, there is no data within that. It's all the data is lost from there. So in case you want to attach a volume, any folder structure from your host machine onto the container, let's say you want to store some logs or anything. When the application is running, some logs will be created, right? So if you want to store those logs, and those logs you want to send it to some kind of a log monitoring or visualization. Let's say you want to send to Splunk or some Prometheus, Grafana, where you want to visualize how your all those logs, access logs, and when the user, when the request came, when the response went, how many users logged in, how many requests were failed, like all those details. Through the logs, you can capture those logs, store it, and then send it to these applications, wherein you can visualize how your application is going, and also CPU and memory and those things like that. So for that thing, you can attach the volumes here. Okay, so we'll look into this one as well. And you can also assign some, whenever your container is running, like you can assign how much CPU quota is required for your container to run, and you can limit how much it requires. Also the memory also is there. So whenever we are running, we'll say how much memories you can assign, memory limit you can assign. Okay, so these are some of the things that we'll look into. But first, let run this container once. Let's see. So we'll go with sudo docker run. Let's go in the detached mode and run the container. You can give some name. You can name to your container like Ubuntu 1, and the image name. Image name is Ubuntu that we have downloaded. Okay. Now it will create. This is the container ID. Okay. If I go and check that, Docker PS. Basically, it exited for some reason. So if you check for this PS-A, it will show all the list of containers, whether it is running or not. For this one is exited. Okay. So what we'll do is, let's go with sudo let's try in the interactive mode. Okay. Now what it has done is, I have connected to the container here. This is the container. This is the ID it has created. And I am now inside the container. So if you run any command here, you can see that only some 2 processes are running inside the container. So that is how lightweight this container is, right? You can create multiple such containers on your host machine. So any questions here on this one? You can see that these only 2 processes are running here. So if I want to exit, I can simply say exit. I'll be back to my host machine. If you want to check the Docker PS, so there will be nothing running there because I have exited from that container. Any question here?
Not for me.
Vikas, Karthik, Vikas is
I don't have any questions, Viresh.
okay. Is it clear or you're
Yeah,
able to get the concept?
it's clear.
Okay, it's clear. All right. Okay. Next in this one, let me see in the Docker. All right. What we'll do is we'll create a repository in the Docker Hub, and then we'll create one image, let's say a Jenkins image, and we will store it to the Docker Hub, and we'll run it. Okay. And we'll see the process how we can upload that image to the Docker Hub. Okay. Let me sign in. Okay. So here there is an option to go to the repositories. So once I've logged in, I can go and create a repository here. It's just like we have the how we have the GitHub, right, where you store all your source code. Same way we can go and create a repository in a Docker Hub. Let's go and create a repository. You can give any name. Let's say I want to create like Apache server or Tomcat server or a Jenkins server. So I can give any name. Let's say I want to install Jenkins, what we are aware of. So we'll say a sample image, a sample Jenkins. Okay, let's give it a name like a repository name as sample Jenkins. Okay. So you can either make it as public or private. So based on that, public, anybody can access it. If they want to search by this name, they'll be able to find it. I think this is not allowed. Let's give it a sample Jenkins. Okay, and then let's go and it's asking to connect to one of these GitHub repository. Let's see.
Viresh, are you there? Hello.
I think his connection is lost.
Yeah, maybe I think organizer is left.
He left long back. You're talking about Boomish.
Haven't received any code. Let's
I think the connection is very slow or something.
Hello, can you
Yeah, can you hear us?
hear me? Hello.
We are able to hear you, Viresh.
Okay, continue tomorrow.
We are able to hear you, Viresh.
Okay, so what I'm saying is we will, but there is a lot of delay.
Yes, it was
In the
there.
background, there is a lot of delays there.
Yes.
Okay. Okay, it is now connected. Okay. So now let me go back to repositories. It should allow to create a repository. Let's see. Okay, it's allowing. So this we'll keep it as public, and now it is connected. So we'll go and create a repository. Okay, so this will be the name when we are trying to push the image. So this will be the name. So this will be the user ID that you logged in, and this is the repository name that we have to take it from there. This is we have created this as a repository. Okay. So how do you create an image? So for that, there are a lot of documentation that we can refer to online. So there's a file called as Docker file. Okay, so we'll go with that one. Okay, so using this Docker file, we can create the images. So here we have got all the commands that we can use in the Docker file. Let's say first, to build an image, so it usually it looks like that. Let me tell you. Yeah.
The background is running very slow.
Or is it? Think.
Now I can see Notepad.
I don't see the recording as well. I don't know whether we started the recording. Okay. So you're able to see the screen right now?
Yeah, now I see a blank Notepad. Yes.
Okay. So let me explain what this image looks like. So whenever we say an image, a Docker image, so it consists of first is any prerequisites. Okay, prerequisites can be, let's say, if you're installing a Jenkins application, so it can be like a Java is a prerequisite, it needs to be installed. And second, so before coming to the prerequisite, we need to have an operating system. We need to have an operating system, a basic operating system. So it can be anything. It can be a lightweight CentOS, or it can be Ubuntu, or the more popular, even nowadays they're using Alpine, is one of the flavor of operating system. It is very lightweight. Even in CentOS also, if you look at it, it will have like at least 100 MB of files which are required for your application to run, along with some security. It's not compromising on the security. It will have the bare minimum files required for your operating system for your application to run. Okay. And third comes the application that you want to application which we want to create as a container. So whenever we say Docker image, first will be always the operating system, and then we'll have a prerequisite, and finally the application. Application here, in our case, we are going to install Jenkins. So it can be anything like Tomcat, Apache, or you want to install like SonarQube, Artifactory, anything you can name off, you can have it as an application. Okay. So now Docker file. So all this image creation is done via file called as Docker file. So in this Docker file, we'll write the commands, so that will create the image. Okay, so let's go and see how we can write a Docker file. Okay, so is everybody okay? Do they have any time so that I can continue?
Yeah, I'm okay.
Okay.
Okay, yeah. So let's see how we can write a Docker file. Say for example, we have taken Jenkins as the application that we want to write a Docker file. Okay, so for that, let's go and see what are the steps. Usually, what we do is, so let's say I want to install Jenkins on CentOS 7. Say for example, okay, I can go to this one, this URL. Okay, here some prerequisites are there. This is updating the system. We are not looking at this option. We'll see how to install Java. Okay, it requires Java for that one, right? So now let's go and write a Docker file here. So let's create a Docker file. Okay, so we'll start writing the first command would be the from command. So in this from command, we'll be getting the operating system from here. Okay. Let's say version 7, I want to pull it from this image. So this one I can say the first layer, that is the operating system that we are pulling from there. Okay, we'll write a simple command. We'll save it. Okay, and let's go and build it now. The command to build the image is sudo docker -t, and we should give the name. Okay, so the name would be the repository that we have here. Okay, just now we went with the Docker Hub. So this is the name of the image we are going to provide. Okay, and a dot indicates you take the Docker file from the current directory. Okay, so dot will take from the current directory. Otherwise, if you have the Docker file at some other path, so you need to give the entire path here to your Docker file. Right now it is in my current directory. I just give it as a dot here. Okay, so let me run this one. Okay, the comment, all this, it's not liking the comment. So let me go and change it. It should be a hash. Okay, it should be hash. See, what it is doing is, for the step 1, it is trying to pull the CentOS 7 operating system. Okay, this is the first layer that we have added. Okay, now let's go and add the second layer. there is any prerequisite. So CentOS has been pulled. Now let's go and install the Java on this one. So to install Java, let's go back to our installation guide. So you can make use of these commands, yum install anything like these commands. So let's copy this and go back to our this one. And there is a command called as run, right? This will run any commands. Say for example, I want to run any command. I can go with this with the run option. Okay. So what this will do is it will go and install the Java there. So now let's save this again. And build the image. So you can see that it is already taking from the cache. Already it is done. So we have built it, and the second step has already started. Okay, now the Java is installed onto the image. There is some problem here. Return the non-zero code. Okay, we haven't passed this option. Okay, that's why it is failing. Let's go back. So yum install. So we need to go with the option yes to install it. Okay, so let's save this now. By the way, is it the daylight saving there? What time it is there right now?
Yeah, daylight set. It's
10:45, I guess.
9:46.
Okay, need 1
Okay,
hour forward.
9:46.
I'm 10:47.
10:47. Oh, okay. Can we do one thing? We will connect half an hour early or 1 hour early so that we'll cover. I think we are lagging behind a little bit. So is it okay that we can cover like connect an hour or half an hour before
Yep.
or later, whichever is fine. Hmm? So that
Yeah,
we'll
we
be
will
able
do
to
that.
cover it. Otherwise,
We'll
But
connect
the
early.
But the only thing is that the Friday and Sunday class confusions, the Friday night, if we don't have, then Sunday we are having, schedule up and down is a bit problematic for me. If you are unable to connect on Friday, if you can let me know a day before, I can stay at my workplace itself. Do some work. If we need to, if we are going to really connect, I'll be back to home at the same time by the time.
So is it okay? Everybody is available on Friday or on Sunday evening?
I'm okay with Friday.
Yeah, even I'm okay with Friday.
Then I'm okay with
Okay,
Friday too.
All right. All right. So we'll connect then. Okay, that's tomorrow evening, right? So you want me to go with the same time and extend half an hour, or we'll connect a little early?
We'll connect
So,
early.
right, we'll connect 30 minutes early. I don't mind.
All right. Yeah, that should be fine then. All right. So we'll go with that.
So, I think 9 p.m. EST.
Mm-hmm.
For you, 8 p.m., right, ma'am? Pushpa Garu?
Oh, no.
Yeah. For her, 8 p.m. For me and Karthik, 9 p.m. For you, you need to check, sir. I think something around 7 a.m. or 6:30.
It should be 6:30 a.m. Yeah, 6:30 a.m. That should be fine. All right. Okay. So what we have done is, all right, we have the prerequisite is done now. Let's see if we can set some Java home kind of thing. Yeah, the Java home and JRE home. We'll set this one as well. So for this, let's go and run this command. Again, we will go with the same run. And we'll source it to memory as well, this command. All right, so let's save this and run the Docker build again. So this is all taken from the cache. This is also taken from the cache. Java is also installed. I think sudo command not found, echo. All right, let's see that. So here we'll just remove the sudo command. Right, you can see that it has run this Java home. So Java home is set, Java JR is now set, and we have also sourced this to the memory there. All right. So now let's look at the final step, that is installing the Jenkins. Okay, so for that we need to add this repository. Okay, this particular repository we need to add it. So this we will take it first. So all this documentation is available here. If you go to the Docker documentation, this one. See, this is a from. If you want to see how the from command is, the documentation for the from command, run command. Okay. Now we'll be using the add command. Add command is basically you will have a source and destination. From the source, it can be any URL. You want to download something and you want to download it to a particular destination. Then you go with the add command. Okay. Let's say from my home directory, I want to copy to the this particular directory on the image, right? Then I can go with this one. So let's go with the add command. I will just clear this. We'll go to the Docker file. In the Docker file, we will say add, and I'll give the URL path. So from this URL, get the Jenkins repository. Okay, and then copy it to the etc path, this particular path. All right. So that's it. So this will be add, and finally I will run the command, this one. So what this will do is it will import the keys. It will import the keys. All right. So once this is done, finally I go and install the Jenkins. Again, for that I can run the command run yum install Jenkins. Because already the repository is available here, once it is downloaded, I can simply go and run the command yum install Jenkins. All right. So let's go and now run this. Okay, it is adding this, it is downloading, and it is also taking the key. Again, we haven't passed the option yes, so that's where it is stopped. Okay, we need to pass install y. So we'll go and give it an option saying that yes, install it. Yum install -y. I'll clear this and run it again. So it will start downloading all the packages. Around 60 MB. Let's it'll take some time. All right, so this is now built. So let's clear this. We can go and check in the sudo docker images that this image is built. It's a little bulky, like around 700 MB. Okay, the image is bulky, but when you run it as a container, you can see what is the difference there. The one final step here, now we want to run it, right? Usually we run Jenkins on 8080 port, right? Okay, so for that we have to expose a port, and that port we can expose using a command called as this is a command, expose the port, like which port you want to expose. Let's say we want to go with the 8080 or 80, whatever the command is, we can go with this expose command. Let's go with this one. We docker file. So now Jenkins is installed, we want to run it. We'll say which port we want to run it. So expose, let's say 8080. Okay. Now remember that this 8080 is on the, once the container is running, it will be there on the container. Okay, so just to avoid the confusion, I will make it as 9000. Okay, we'll see what is the difference there. Okay, so let me save this. All right, so let's run it for the build it again finally. Okay. So now it is exposed on the port 900, right? Okay, so now the image is ready and we can now run it. So for that, let's simply go to the docker images. Okay, so this is the docker image we have. We will run it now in a detached mode. Docker run -d. Here is the port we are saying. This -p is the port How you'll read it is on my 8080 is already running, right? I can take, let's see what other port is there. Maybe to expose some port. Let's go to the firewall. Uh, 8080 is running. So let me take some other port. We'll create one more firewall rule here. Give it a name as like Docker Jenkins. Priority is fine. Ingress, that is direction is ingress. That is your allowing the traffic to go to the container. Okay, specify targets. Say all instances on the network. IP range again. We'll go with the default one for now. So TCP. Let's say 8081. Okay, we'll open this port 8081. You can take anything 9000 and 850 or any port, but for now let's take it as 8081 and create it. Okay, the rule has been created. So now if you go back here, so instead of 8080, I'll go with 8081, and 9000 is a port name we gave on the container, right? So the request will be routed from my local host 8081 to the 9000 onto the container. Okay, and what is the repository? This is the image I want to run it. Okay, I'll just copy that image, right? That's it. So we will now run this one. So you can go in the interactive mode as well. If you want to go with the interactive mode, you can go with the interactive mode. Let's say, let's turn in the detached mode and see first. You can see that it has now, this is the container ID. So sudo docker ps. Maybe it is, okay. Okay, it ran for some time and it again, it exited. Let's, okay, let's add an entry point here. So entry point will be any command that you want to run when the container has been started. Okay, so for that, let's go with the, we can go with either entry point or there is something called as command as well. So you can go with any one of these. So in the command, let me say, let's give an example. So we'll go with the command. Let's go with the command. Say I want to run bin bash. Build it first again. Okay, it is built. Now let's go and run it. There seems to be some issue with this running of the container. Let's see if I can pull from Jenkins here. What is the Jenkins? So you can also find the Docker file here. So if you want to refer something, you can go with this one. Let's say I want to look at the latest Docker file. Okay, so this is how the Docker looks like. Taking care of all those group ads, skins home, ports and everything, deleting all those and everything. Have as well. Okay, so entry point, they are going with the local bin bash. Okay, let's try to run this. I think I have to change a little bit on my image. Let's try to run this image and see how it works. So what I'll do is sudo docker pull Jenkins. So by the time it completes, let's see how it can be run. Let's go back. You can simply run it this way, docker run Jenkins, or you can attach some volumes as well. Okay, so now let's go and run it. Yeah, it's completed. So if I want to run this, I can go with sudo docker run. Let's run in the detached mode. Yeah, 8080 is it. So let's run with 8080. It's a Jenkins. Okay, so this seems to be running now. It's up and running. So this is the container ID. So if I go to this URL now, you should be able to see the Jenkins running there. So if I go here, localhost. So if I go to 8081, So you'll get that initial page here again. So I can go this and I can continue. So I can run any command on the container with this execute command -it. Let's say this is a container ID. Okay, and I will go with the cat command. I'll copy this path and I'll place it here. Okay, so what this will do is it will go and run this command on the container. So I'm going in an interactive mode wherein I'm passing this input to the container, and the output I can see here. This is the key I have got. So this key I can copy it and I can place it here. So that's how it is. Now your Jenkins is running as a container, right? So this is how you can create a container. The one we created, I think there is slight change there. I will have to modify the entry point, so that we'll see in the tomorrow's class what was the issue there. But basically, if you want to run it as a container, so you need to provide, this is the host port and this is the port on the container. Okay, and you can run in the detached mode in the background, and once the container is running, you can run any command on that container using the execute command like this. Okay, so finally you can see that your container is up and running. So if I go and stop this container now, this one, you should see that you will not be able to connect to that container. If I go and stop, let's say this one, okay, it is stopped. If I go and refresh it, you'll find nothing there. So that container is completely in a stopped state there. All right, any questions?
Nothing right now, Virish.
Not right
All right,
now.
I think we will stop it here. Okay, I know it's pretty late for you guys. We'll stop it here. Tomorrow's session, we will have a look at how we can upload, or we'll try to rectify that image, and we'll upload that image to the Docker Hub. That's one thing. And we'll have a look at some of the networking concepts in Docker, right? How we can connect via networks and what a network plays a role in Docker. Okay, that concept we'll see tomorrow. Okay. All right, we'll connect half an hour early then. See you tomorrow early, like half an hour.
Okay.
Yeah. Thank you guys. Thanks for joining.
Thank you.
Thank you.
Thank you.
Thanks. Bye. Bye-bye.